Welcome to today's Explainer. We usually think of history as this long timeline of, well, wars, empires rising and falling, big political revolutions. But today, we're doing something a little bit different. We're going to look at one single calendar date, June 25th, and discover how a handful of brilliant mathematical geniuses quietly built the entire modern world we live in today.
Okay, let's dive right into this. I know it sounds like an absolute statistical impossibility, but on this one specific date, across completely different centuries and radically different countries, these brilliant minds were asking questions that literally changed our reality. We're going to meet them one by one. And the crazy part? Every single person we're talking about today was either born or died on this exact same day, June 25th.
But before we get into the heavy math of it all, let's actually start with a modern wonder. Have you ever wondered why your Spotify or Apple Music sounds so unbelievably clear, even when you're stuck on a really slow, spotty internet connection? Just think about how massive, high-quality audio files actually are. How in the world can we stream that crystal-clear audio straight to our smartphones in real time without terrible static, buffering, or interference just totally ruining the song?
Well, the answer takes us back to June 25, 1931, and a guy named Anatoli Vitushkin. Now, he wasn't just a brilliant Russian mathematician, he was a guy who deeply, truly loved music. In fact, he was constantly tinkering with and trying to perfect his own household musical apparatuses. He was obsessed with figuring out how to capture the absolute purest sound possible, without being held back by the clunky, technological limits of his time.
So here's where his genius really kicks in. He showed us how to translate complex, continuous sound waves into simple digital codes. See, traditional analog recording picked up way too much background noise. It was kind of like trying to trace a beautiful, intricate drawing on a super bumpy table. So he developed a mathematical model to code signals with a finite spectrum. It's basically like turning that continuous drawing into a really precise connect-the-dots grid. It allows a computer to recreate it perfectly every single time, completely immune to all that outside interference.
Vitushkin's mathematical breakthroughs essentially gave us the literal blueprint for modern digital audio. So the really crucial takeaway here is that his work on the complexity of tabulation algorithms is what makes pristine digital sound possible today. Whether you're streaming this very explainer right now or blasting your absolute favorite album, every song you hear is secretly just an elegant, complex math equation being decoded on your phone in real time. How cool is that?
But, June 25th isn't just about the digital age. Let's actually jump backward in time for a second. We're going from the birth of modern audio in 1931 all the way back to the year 1671 to solve a totally different mystery. It's the exact same date, but a wildly different era, where the biggest unknowns weren't hiding inside wires, but way up in the night sky.
Think for a second about our highly advanced modern space apps and orbital satellites. Before we had GPS, or high-tech rovers, or imaging satellites to guide us, how did we organize and map the final frontier of space? More specifically, how do astronomers and astronauts today know exactly what to call the massive craters and sprawling valleys on the moon, a place no human had even touched back then?
The answer goes back to a man who passed away on this exact date, Italian astronomer Giovanni Battista Riccioli, who died on June 25, 1671. Night after night, Riccioli would just spend hours staring through these early, honestly incredibly rudimentary telescopes, meticulously trying to map a distant, alien world that no human being had ever set foot on. His entire life's work culminated when he published this massive astronomy encyclopedia called the Almagestum Novum. Inside this colossal book, he created unbelievably detailed maps of the moon's surface. But even better than that, he developed a really specific, logical naming scheme for it all. Because of him, we have famous lunar landmarks like the Sea of Tranquility, and we have major craters named in honor of legendary scientists and astronomers like Copernicus and Kepler. And honestly, this brilliantly illustrates just how deeply his work survived the test of time. We literally still use his exact naming scheme in our planetary science classes in our multi-billion-dollar space programs today. The labels you see on our modern lunar maps, yeah, those were written all the way back in the 1600s. All right, still on the same date, but let's jump forward to a very special double birth year. On June 25th, 1908, two completely different thinkers were born on the exact same day, and both would go on to shape modern computing, just in vastly different ways. Let's meet the first of these brilliant minds.
Think about how our complex apps make those incredibly fast, smart decisions, like how do navigation apps like Google Maps or incredibly advanced AI search engines find the absolute best route or the perfect answer. How do they instantly find a needle in a haystack without getting just totally overwhelmed by the massive, endless amounts of data out there? Well, this brings us to Finnish mathematician Gustav Elfving, born on June 25, 1908. Elfving was deeply fascinated by the laws of probability and statistics. He was completely driven by this desire to figure out how we could draw perfect conclusions from a really imperfect, messy world.
So he pioneered this revolutionary concept called the optimal design of experiments. Think of it kind of like trying to predict a massive storm coming in. Instead of spending millions of dollars to put 1,000 thermometers literally everywhere, Elfving used elegant geometry and calculus to figure out the exact 3 spots you'd need to place them. He figured out how to distribute observations to get a perfectly accurate prediction, using the absolute least amount of effort and minimizing random error.
This pursuit of maximum efficiency and minimum effort is truly the math of perfect planning. And today, Elfving's algorithms are the foundational stepping stones for the computer efficiency and the machine learning models that we rely on every single day to optimize our modern lives.
Meanwhile, thousands of miles across the globe, on that exact same day of June 25, 1908, another brilliant mathematical mind was taking his very first breath. And while Elfving was optimizing statistical data, this newborn would eventually grow up to find himself fighting in a deadly, high-stakes secret war.
Have you ever thought about how our private, encrypted online chats stay secure? I mean, when you send your banking details, or confidential emails, or secure passwords, how are they scrambled so efficiently? How do those messages stay perfectly hidden from malicious hackers who are just trying to intercept your daily life?
Meet Willard van Quine, born on the exact same day as Elfving, June 25, 1908. Now, you'd probably expect a pure mathematician or maybe a mechanical engineer to be the one breaking complex enemy codes, right? But Quine was actually a philosopher and a profound logician.
During World War II, Quine served in Navy intelligence. At the time, the German submarines were using highly complicated Enigma machines, and the settings on these machines completely changed every single day. But using his brilliant background in logic, Quine relentlessly analyzed intercepted messages. For instance, if he knew an enemy submarine was on a rendezvous, he used sheer logic to guess that a single scrambled word in the message might just be refueling. By knowing that one logical word, the math allowed his team to guess the exact settings, unravel the entire daily Enigma cipher, and save countless Allied lives.
The sheer logic Quine used to crack those wartime submarine codes didn't just help win a global war, it actually laid the direct groundwork for modern digital cryptography. The exact same logical principles and code-breaking frameworks he used are actively protecting your daily WhatsApp chats, your personal emails, and your private bank accounts right now.
So, bringing it all together. Every single person we've met today on this incredible date, spanning across completely different centuries and totally different countries, all fundamentally asked the exact same question. What is the pattern hiding inside the chaos?
Whether it was the overwhelming chaos of the uncharted night sky, a terrifying jumble of intercepted wartime letters, a sprawling mountain of random statistical data, or even just the continuous, messy analog waves of musical sound, they all used mathematics to cut through the noise and find the hidden order.
And because they dared to thoroughly investigate these mysteries, because they asked the right questions, our world today is defined by their answers. We have deep space exploration, a completely secure internet, incredibly efficient AI algorithms, and the beautiful, crystal-clear music currently streaming right into your ears. It leaves us with one final, really exciting thought as we wrap up this explainer. The math of the universe is still out there, just waiting to be discovered. Who among you will be the next to use math to find a hidden pattern, unlock a brand new mystery, and completely change our world? Thanks so much for joining me on this incredible journey through June 25th. See you next time.